Sample problem 7.02. The figure shows two industrial spies sliding an initially stationary 225 kilogram a floor shape at displacement d vector of magnitude 8.5 meter. The push F1 vector of the spy 001 is 12 Newton at an angle of 30 degree downward from the horizontal, and the pull F2 vector of the spy 002 is 10 Newton at 40 degree above the horizontal. The magnitudes and the directions of these forces do not change as the floor safe moves, and the floor and the safe makes a frictionless contact. What is the net work done on the safe by the force F1 and F2 during the displacement d vector? So what is given here? Here there are two spies. They try to move these floor shapes. That means this is the object. And this object mass here they mentioned 225 kilogram. That means the mass of the safe, which is 225 kilogram. And then they move this safe to the right direction. By that, the displacement takes place, and the magnitude of the displacement d vector here is mentioned as 8.5 meter. Clear? And here, when the first person, which is spy 001, he applied the force in this direction. That means they clearly mention the person one, that means the spy one, he applied the force in this direction with respect to an angle of 30 degree downward to the horizontal direction. That's the reason the diagram is given like this. So he applied the force in this direction, which is F1, and how much magnitude he applied? The magnitude of the first force is 12 Newton, and then we have to see the second person force. He applied the force above the horizontal with respect to an angle of 40 degree, and by that he applied the force value magnitude, which is 10 Newton. So we have to write that given also. That means F1 magnitude here is 12 Newton and its corresponding angle theta 1 is 30 degree. Likewise, F2 magnitude here they mentioned 10 Newton and its corresponding angle theta 2 is 40 degree. By using these informations, we have to find what is the work done by the first person, what is the work done by the second person. That means the spy 1 work done, as well as we have to find the spy 2 work done, and after that we have to find the net work done. So for that we have to use the rule W, which is equal to FD cosine theta. So I have to use this formula for these two forces. So let's we apply this formula for the first force, which is W1, which is equal to F1 multiplied by D cosine of theta 1. Now I am going to substitute the value here. What is the value of F1? Which is a 12 Newton multiplied by the displacement value is 8.5 meter multiplied by cosine of the theta 1 value is 30 degree. So when you multiply all these, we got the answer here as 88.33 joules. So this is the answer for W1. Likewise, we have to find the same values, the same rule for the second force, which is W2, which is F2 multiplied by D cosine of theta 2. Now I have to substitute the value here as we know the given. So the F2 value here they mention as 10 Newton multiplied by the displacement value is 8.5 multiplied by cosine of 40 degree. We got the answer here as 65.11 joules. So this is our W2 value. Now once we find W1 and W2, we have to find the net work done, which is W net, which is equal to W1 plus W2. So here the W1 value is 88.33 plus W2 value is 65.11, and we got the answer here as 153.44 joules. So this is the answer for the net work done for these two forces, which is acting on the floor safe, which has the mass of 225 kilogram. Clear? Now we have one more question, which is part B. So let's read what is given here. During the displacement, what is the work done on the safe by the gravitational force? And also we have to find what is the work done by the normal force. So that means we have to draw the free body diagram. So what is given in the diagram? We had a horizontal flow. That means the surface is horizontal, and over the horizontal floor we have the safe, and we applied force this direction, and one F1 will be in this direction and F2 will be in this direction. And here this is our normal force, which is Fn, and this is our force due to gravity. So now they ask what is the work done by the normal force, what is the work done by the gravity, and also the displacement of the block will be in this direction. So now you can see the angle between Fn as well as the D is 90 degree, right? Likewise, the angle between the gravity force as well as the displacement is also 90 degree. So when you substitute the values in the given formula, what is the formula? We know the work done by the gravity. Here we mention mg d cosine theta. Likewise, the normal force formula here, Wn, which is equal to Fn d cosine theta. So here for both normal force as well as the gravity force, the theta is 90 degree, right? So when you substitute 90 degree here, the cosine of 90 degree, which is equal to 0. Likewise, here also the cosine of 90 degree is equal to 0. So the most important thing, you have to see the direction of the force as well as the direction of the displacement. So for normal force as well as the force due to gravity, based on the direction of the displacement, both force is acting on this block with respect to 90 degree. So that means the cosine of 90 degree is 0. So you don't need to substitute the value here. Once you substitute the angle here, the cosine of 90 becomes 0. So anything multiplied by some number, because we already have the value of the mass as well as we have the value of the gravity, we know the displacement value, but whatever it may be, whenever you multiply anything with 0, what is the answer? The answer is also 0. So likewise, the same thing here, when you multiply anything with 0, 0. So that means the answer for work done by the gravity, work done by the normal force, for the displacement d vector, which is equal to 0. So this is the answer for this question. That's it. Thank you.